Hey guys, hope you're doing well. We're going to go over some more problems in this lesson today on special triangles. Alright, so we're talking about right triangles, but we're talking about specific right triangles that have some unique properties to them. And first we're going to look at a 45, 45, 90 degree triangle. As you guys might suspect, since it's a 45, 45, 90 triangle, it is an isosceles triangle, which means you have two legs that are equal. Now there is a relationship to the two legs and the hypotenuse all the time, and let me show you where it comes from real quick here. Alright, so if we use our good old Pythagorean theorem, which you guys learned about a lot in the last little video I posted here, a squared plus b squared equals c squared. Alright, here a and b are both x. Okay, so we have x squared plus x squared, and that's equal to the hypotenuse here, which is BC. So we'll put BC squared. All right. So x squared plus x squared we could write as 2x squared, right? And that's equal to BC squared. All right. So if we wanted to represent the hypotenuse, okay, in relationship to the legs, the two smaller sides there, we could rewrite this, okay, we take the square root of both sides, square root of both sides, all right, and the square root of x squared is simply x, okay, because the square root undoes the square, so BC is equal to x times the square root of 2. In other words, the hypotenuse is always the square root of 2 times whatever the leg is, okay? So the leg is x. The hypotenuse is square root of 2 times x. Now remember, this only applies for 45, 45, 90 degree triangles. So this theorem here basically shows you exactly what I just said. All right, the hypotenuse is, if a side is s, the hypotenuse is going to be s times the square root of 2. All right, now that could be 4, it could be 5 times the square root of 2. It all depends on what the leg is. So hopefully that makes sense to you. All right, so we're going to use that now to figure out a couple of these triangles here. All right, so let's see. Okay, so xy is 7. All right, xz, guess what? Because it's an isosceles triangle, xz is also 7. All right, that's the easy one. All right, and using that theorem that we just talked about, all right, yz is going to be the side, 7, multiplied by what? The square root of 2. All right? So yz is 7 times the square root of 2. And then you could actually get a decimal approximation for that if you want to with your calculator. Just make sure to put in the square root key. All right? So there you go. Now, in this particular one, we are given the hypotenuse, okay? And we have to find JK and LK. So let's think about this for a second. All right, so if we multiplied by the square root of 2 to find the hypotenuse, guess what we're going to do to find one of the legs? We're going to divide by the square root of 2. All right, so we have 12 times the square root of 2. And if we want to find one of the legs, we need to divide by the square root of 2. All right? So JK is simply 12 here, which is the same thing as KL. All right? Now, if you look at this example in the book, they would probably format it like this. Something like this they would start out with. They'll say JK times the square root of 2 is equal to the hypotenuse, which is 12 times the square root of 2. Okay, of course you could put LK instead of JK if you want to in that same equation, but to solve this equation you would divide by the square root of 2 and essentially get what we have, which is 12, okay, for those two. All right, so let's move on to 30, 60, 90 triangles. 30, 60, 90 triangles have a relationship as well. So 30, 60, 90, we're talking about the degrees. All right, it's a little bit more complicated, but it's not so bad. All right, so the side across from the 30-degree angle we're going to call S. Okay, so we're going to start with the shorter side being S. You always want to have the shorter side being S. Then compare stuff to the shorter side. Okay, so if we're comparing to the shorter side, the middle side is always the square root of 3. So like the middle side will always be across this from the 60-degree angle. Okay, it's S times the square root of 3. And the hypotenuse is always double what the shorter side is. Okay, now it goes in order. Okay, the largest angle goes with the largest side. The shortest side is opposite the smallest angle, S. Middle side is opposite the middle angle, which is S squared root of 3. And the square root of 3 is really about 1.73S, okay? The largest side is opposite the largest angle, which is 2S. So you need to remember this relationship here, okay, in order to solve the problems that you're about to see here. All right, so what are PQ and PR? Okay, so PQ, okay, PQ is the middle side, the middlemost length side here. So what we're going to do is we're going to take the short side. Okay, so PQ is equal to square root of 3 times the short side, which is QR. Okay, so in other words, it's just the square root of 3 times 6. Or it might prefer, when you write radicals, it's best to put the number that isn't in the radical in front of it. Okay, all right, so that's PQ. Now, what is RP? All right, RP is the hypotenuse. RP, remember, based on that theorem, is just double PR. So that would mean that RP is equal to 2 times 6, which is 12. Okay, so hopefully that isn't so bad. All right, for this one, we're looking for UV and TV. All right, so we're given TU. Now, is TU the shortest side? No, TU is actually the middle side. You always want to find the short side first, okay? So the short side is what you want to figure out first. So VU, if you take VU, which is the shortest side, and you multiply it by the square root of 3, you would get what TU is equal to, okay, which is the middle side. Because the middle side, remember, is always square root of 3 times the short side. So it's equal to 9 times the square root of 3 here. All right. And in order to solve this, we would divide by the square root of 3. So you always want to figure out the short side first. And when you're figuring out the short side, you're always doing division to figure it out, okay? So the short side is equal to 9. And then once you have the short side, to figure out the hypotenuse, remember, is double the short side, 2 times VU, which is 18. Okay, so hopefully that isn't so bad there. Okay, now we're going to apply these special right triangles to some situations to make them useful here. All right, so Alejandro is trying to build a ramp with some 12 foot of wood. Does he have enough wood? All right, and they give you the hypotenuse is 10 feet, and we have a 30, 60, 90 triangle. So we're using the same relationships that we did before. All right, so we need to figure out the other two sides. And if we're not given the shortest side, you always find it first by division. And once you do have the short side, you multiply to find the other side. All right, so let's take a look here at first how to get the short side, which is AB. Okay, so BC, the hypotenuse is 2AB. So you're just going to divide it by 2. So the short side is equal to 5. And then you would multiply 5 times the square root of 3 to get the middle side. All right. Now, does he have enough wood? Well, let's find out. All right. So I added up the short side and the middle side, and I got 13 and 7/10 feet. He's not going to have enough wood. You don't need to add the ramp in there. I was thinking of adding 10 too, but he's just getting supports for the ramp. Okay. So, but anyhow, he's not going to have enough wood. All right. Let's look at the next one here. All right. So we're doing some origami. 200 millimeter diagonal fold. What are the side lengths and the area of the square? All right. Now remember, Okay, so the diagonal here is essentially the hypotenuse, and that's 200, okay? And if we want to find the sides, okay, remember in a 45, 45, 90 triangle, okay, the relationship is if this is S here, this is square root of 2 multiplied by S, okay? Whereas if you had a 30, 60, 90 triangle, and I labeled my 30 and 60 backwards. Bad, Mr. Yakko. That should be a 30-degree angle. Okay, but anyhow, if this is S, the hypotenuse is double S, and the middle side here, it would be S times the square root of 3. Okay, so you want to make sure to get these things clear. Of course, in the 45, 45, 90 triangle, this other side would be S as well. All right, so if we know the diagonal, the hypotenuse is 200, to figure out each of the legs, we have to simply divide by the square root of 2. All right, so the side would be 200 divided by the square root of 2. You'll get about 141.42 millimeters. That's just an estimate because you're dividing by a square root. And then if you want to find the area, it's just going to be length times width, or one side squared, side times side. Okay, and it ends up being 20,000 millimeters squared for this origami. Okay guys, here are 2 try it problems. I want you to pause the video and give it your best shot with some pencil and paper. Don't just guess here. Alright, let's go over the answers for these try-its. This is a 30, 60, 90 triangle, so remember, if you want to find the shortest side first, okay, and this is the shortest side because it's across from the 30-degree angle. This is the middle side because it's across from the 60-degree angle. Alright, so this side here is 2S. So BC, the short side, is just going to be 28 divided by 2, okay? Because the middle side is 2S, so the short side is half of that. So that is 14, okay? Now, if I want to find the hypotenuse is just equal to the short side times the square root of 3. Okay, so it'd be 14 times the square root of 3. All right, let's look at this one down here. Okay, make sure you go ahead and try it without my help here, and we'll see what you get. All right. AC and BC, they are both the same, okay? AC and BC, these are both S, okay, because they are across from the 45-degree angles. The hypotenuse is S times the square root of 2. So if we're finding the short side, we are dividing by the square root of 2. All right, so I know that looks like a 2 there, or 5, but that's an S. If you hear me, that's an S, okay? All right, so if we're finding a side, okay, so AC is just going to be the hypotenuse divided by the square root of 2. All right, and that's actually going to be the same thing as BC, okay? And, just go ahead and put that in your calculator, see what you get. I got 9.9, so 9.9 is approximately BC. All right, well, that's it, guys. Hope you have a great day. Tomorrow you'll actually get to practice some of these problems. And just remember, something. Nothing profound today. All right. Take care now. Bye.